How y'all doing? Awesome. How about those keynotes this morning, huh? Okay. I recognize some of you guys from yesterday. This is going to be fun. We're going to talk about REST APIs today. A couple different ways about going about them. We've got SaltAPI. Have any of you guys ever used SaltAPI before? See a show of hands. Excellent. That's a little over half. How about the new salt.utils.http stuff? Has anyone, first off, has anyone heard of it? Looked at it? Has anyone actually used it? Okay. We'll talk about kind of the mindset behind why that was added in this release, and where I think you might be able to go with it. We'll talk a little bit about SaltAPI as well. Not a whole lot of demos in this session. We're going to talk about concepts and theories and configuration. Okay. So first off, let's talk about what REST is. Does anyone remember web program before REST? Yeah, that was good times, right? I remember when REST came out, and I wasn't actually a big fan because REST, kind of the big thing behind it is they just take some of the old HTTP methods and kind of overload them and use them for things they were never really meant to do. And I thought it felt kind of hackish, but it's worked out pretty well. And when JSON came on the scene, and well, I'm not sad to see XML kind of go by the wayside. We'll put it that way. XML was really awesome when it came out, but considering what we had before, did any of you guys remember EDI? We're talking about white space padded column files, ASCII files. It's something that was developed back in the 70s and should have gone by the wayside with XML, and it's still really popular in the healthcare industry, where obviously we want the latest technology. And there's other industries that use it a lot. JSON is just awesome, though. I'm really excited about it. I came from a Perl background. You guys can laugh now, get it out of your system. But I was really excited when I moved over to Python and was getting into JSON in both areas. And it's kind of nice to see this data structure that was similar between the two platforms, the two different languages. I like REST because it's lightweight. It's being lightweight, it helps it be scalable. It's very accurate. You guys have all used Salt a little bit, right? We all use the YAML. YAML is nice because it's easy to read. I like it because it's like bullet points. If you know how to make bullet points, then you're halfway there on YAML. The problem with YAML is it's not incredibly accurate. It's really easy to get yourself into trouble, especially when you have a line item that goes down to line number 2. It's really easy to screw things up in there. And JSON, do you guys know that JSON is syntactically correct YAML? All JSON is YAML, but it's YAML that doesn't get you into trouble. So that's pretty awesome. So I'm really happy about using JSON. There's other serialization methods available. JSON is really kind of the big winner at this point, but there's still some APIs that are based on XML, and there's still a lot of good toolkits to use them. I've worked with a lot of customers that use primarily JSON and XML, and this SaltUtils HTTP library that I've started to put together is kind of designed around the needs that I've seen. So there's two ways of dealing with REST with Salt, and I'm kind of excited about both of these showing up. SaltAPI has been around for a couple of years now. It's essentially a client for Salt that allows you to use Salt over REST interface. I think most of us are used to using Salt from the command line, but does anyone have all their admins log in to the Salt master and use it directly on the Salt master? You can raise your hand, that's fine. Like 2 people, 3, okay. People are getting less shy. How about using like the peer interface? A couple of you guys, okay, I see one guy using the peer interface. This was just another method that came out for us to be able to control the Salt Master without actually asking people to log into the Salt Master, right? There were a couple different libraries that were built on top of that. Salt UI came and went pretty fast. You guys remember Halite? It's no longer under active development. And I haven't spent a whole lot of time looking at the enterprise UI, but I wouldn't be surprised if you used it pretty extensively. We've started to get into SaltAPI quite a bit more. It's kind of cool configuring SaltAPI too, because it uses this pluggable backend, this external auth backend. Have you guys played with external auth a whole lot? There's a few different plugins for it, but by and large, the ones that people use are LDAP and PAM. And since PAM does LDAP, people just use the PAM one, right? In fact, if you're in Linux, you're just going to use the PAM one, which is cool because it makes SaltAPI just that much easier to set up. salt.utils.http is it's a wrapper. It's designed to allow us to make more salty calls to other interfaces and integrate them into Salt in a way that makes sense from a Salt point of view. It's a wrapper that's got a couple of different backends. It supports requests, and it supports URLib2. Who here is a big fan of requests? A lot of request fans. How about URLib2? Why don't we use URLib2? What? Say it again. It doesn't directly support HTTPS, right? And that's been true up until Python 2.7.9. And now it can actually support it. It's got Python K with stuff built in. However, and in fact, they backported it so you can use it in previous Python versions. In fact, all the way back to Python 2.5. And has anyone tried to set that up? Yeah, it's a kind of a pain. Normally, you would import things from SSL, and now you import it from backports underscore SSL underscore hostname, I think. It's kind of a pain to deal with. There's other issues with requests that are kind of interesting. Have any of you guys ever tried to use requests in Windows? What's that? Stop swearing. It actually does work really well in Windows, as long as you have it pointed to the certificate paths. And setting up the certificate paths is actually not that hard. You just have to go find them, point requests over to it, and everything's taken care of. You don't have this problem with the Linux platforms because requests, the way they go about this is they have this file that points directly to the library. It's hard-coded in there. And it says right in the file, if you're packaging this for a distribution, make sure you point this to the SSL files. And so people that build it for Ubuntu or they build it for Red Hat or whatever, they point it over to the right files, and everything works smoothly. And when you start to step outside of that nicely packaged stuff, it falls down really quickly. Fortunately, requests is easy to set up to use the certificates right, and URLib2 is actually really easy to set up properly as well. Any of you guys use libcloud outside of SaltCloud? libcloud uses URLib2, and it has its own SSL wrapper around it, so it can handle the match host name thing really well. What it came down to, though, there were pros and cons for URLib2 versus requests, and we wanted to be able to deal with either one. Some people really, actually most people really like requests. Some people really like URLib2, and so they're both available. We defaulted it to URLib2, and in fact, we ship the match host name stuff with Salt now, so that we don't have to worry about all that madness. But we defaulted it to URLib2 because that's just one less dependency to deal with. However, you can switch it over to requests just with one flag. Okay, so let's talk about salt.utils.http, and I might do some code diving in here. This was designed to standardize web calls within Salt. Have any of you guys worked with any of the Salt libraries that do web calls, by which I generally mean SaltCloud? Just me? There was a lot of madness a couple years ago because there are a lot of different libraries. They do a lot of different calls. It was kind of the same Wild West that, you guys remember command.run 3 years ago? Anyone? it was a weird popen wrapper, and some places used command.run, and some places in Salt used popen, and some places used subprocess, and it got all standardized down to command.run, and now when something breaks, we can just fix it in command.run. That's the same kind of problem we had with web calls. Salt is not something that's normally known for web calls, but it's something that does need to happen under the hood, and so we decided to start standardizing things and start moving everything over to the library. Not everything is moved over just yet. This is a fairly new library, but things are getting moved over. Okay, it adds some features that you don't normally find in web browsers. These are things that you would not normally want in web browsers, like it does automatic JSON decoding into a Python dict. You don't normally need that when you're Googling for something, right? It also offers automatic XML decoding. In fact, it tries to figure out which one it's looking at and do the right thing. And that's something that it's really useful for those of us working with Salt, but it's not incredibly useful for other browsing. In fact, it's not really all that useful probably for the requests community at large. They have other stuff they need to do, and they usually have their own ways of doing it. We also have some things that take advantage of some built-ins in Salt. If I don't see them in the slides, I don't remember what's on the slides. I built them like long enough ago that I don't remember. But if we don't get to them inside here, we'll go and do some code diving and take a look. Things like, have any of you guys played around with Salt's rendering system? What is Salt's default renderer? YAML and Jinja. I heard some YAML and Jinja, right? What other renderers have people used? Does anyone here use Mako? Mako? Strong preference for Mako. How about, does anyone do salt states in JSON? I'm sorry? PyObjects. PyObjects is a great one. You guys know there's 3 different Python renderers in Salt. There's PyObjects, there's the PyDSL, which is the first one, and then there's the pure Python one. It's kind of interesting looking back in the history of Salt. We didn't originally have a DSL. I don't think you could really call the YAML stuff a DSL. It's kind of, sort of, but not really. And somebody came in from, I want to say they came in from a chef background, and they really loved having that ability to just write code, and so they added the PyDSL stuff. And that was the only DSL in Salt for probably about a year before somebody came in at about the same time, added PyObjects and Py. So these libraries are all available through different subsets of the HTTP library in here. So Salt-specific stuff, headers and data. We all deal with, who here has used curl? Curl-D. We pass through data files. We pass through headers in a different way. I had a customer that I was dealing with last year who we didn't actually have to do a huge amount of work. We went into this engagement thinking that we had massive amounts of things to do. And what it came down to for my part was making 3 or 4 web calls. And that was about it. And we ended up putting together this library and putting together a set of templates, or a set of headers that was just a Jinja template. And then the post data, we just made another Jinja template. They were using XML in their interface. And so what we decided to do is allow people to pass through headers and data, just pass through an actual file, and run it through the rendering engine. So all of Salt's renderers are available. If you want to do your headers in Python for some reason, by all means. And there may be, I don't know that you'd want to do headers like that, but there may be some reason that you want to do that. Around that time, we also had a customer that was migrating from Cheetah and something else. Any of you guys ever use Cheetah? It's kind of, you like? A lot like Mako. It's not as popular as some of the other ones, but they had a need for it, and so we added it in there, and that's available now. And if you're dealing with an XML type API, that might work really well. Templates have access to the Salt hops, just like we're used to in other parts of Salt. If you want to call out to, depending on what it is in the library you're looking at, whether it's called Salt or Dunder Salt, those are available. There's 2 different cookie jars that are available. This is unholy, and I realize it's unholy, but I'll tell you why I did it. You guys know what the difference is between a regular cookie and a session cookie, right? Ryan? What's the difference? A regular cookie and a session cookie. Specific to authentication, so it needs to be more secure. That's not what I'm looking for. It is true. Yes? Shorter lived, meaning the session cookie is only valid as long as the browser is open, which is why it goes into security like that. It has no expiration. That's really the big difference, is that it has no expiration. However, look at the architecture of Salt at this point in time. What happens when you call a Salt execution module? It calls out to a minion, it does stuff, it returns back. Have any of you guys looked at the Salt Fuse project that was started up about a year or so ago? It kind of pretends that it's a file system sitting on top of Salt, but it doesn't have this capability of file locking, which is really necessary to a file system, because file locking would require us to reliably ask the minion the same process over and over again to keep control of a file. Salt fires off a job, it returns back data, you're done. And when you're dealing with a browser like this, that means the session cookies are basically invalid. You can't use them, right? And so we needed the ability to persist session cookies between different web calls. That's why we have two different cookie jars. We have and these are just the cookie jars that are built into Python. We have the Mozilla cookie jar, and we have the LWP cookie jar. You guys know LWP? I saw a hand kind of nervously go up and down. What's LWP? libwww Perl. Got a lot of Perl guys in here? Yeah, no. It's actually a great cookie jar to use because it's plain text, it's easy to read, it's really great for debugging, and outside of that, it's entirely useless. Even the documentations inside Perl will say, don't try to use this for anything real. We just put this together for testing because we needed something like this. But it's available in Python and you can use it. The Mozilla one is great because if you have a browser that uses the Mozilla cookie jar, and I'm not sure that a whole lot do at this point, but if you do, you can just import over that cookie jar. So both of those are available to you. And use them wisely. Again, persisting session cookies across multiple calls like this, it is unholy, and you should decide whether or not you actually should be doing that. And again, I mentioned there's automatic JSON and XML decoding available. It tries to figure out, based on the headers, which one it's looking at. And if it can't figure out, it's just going to assume that we're looking at plain text. So I talked about how it wraps both URL-lib2 and requests. It's available pretty much all over the place. The main library is salt.utils.http. There's an execution module that it wraps it. It has some ** quargs, and that's it. Runner module, same thing. There's a monitoring state, which is actually reasonably powerful. And I think that as people start to use it, they're going to see a lot more power in it. Using the modules, you can use it from the command line. I don't know that that's necessarily the best way to use it, using the execution module or the runner module. You can just say http.query, give it a URL, and you're good. You can also start passing through the method you're going to be using. You can start passing through a list of headers, a dictionary of headers, a header file. You can pass through your post data directly. You can pass it through as a file. The state. Have any of you guys worked with monitoring states? Do any of you guys know what monitoring states are? Monitoring states have been in Salt for probably about a year and a half, and they are not well known, which is really unfortunate because monitoring states can be really powerful. The idea behind a state is that we're trying to enforce a particular configuration, right? We're trying to say this state needs to look, or this machine needs to look like this. It needs to have these packages installed. It needs to have these files looking like this. It needs to have these services running. That's what a state normally does. A monitoring state, it's called the same way, just using state.highstate, state.whatever, but its job is only to look and see what state something is in and report back on it. And some of the monitoring states have this ability to say, okay, pass me some parameters, and if we are not within those parameters, then we raise a fail, right? For instance, we can say acceptable parameters for load average are between 2 and 5. This is a pretty heavy server. We know that if it drops below 2, then generally speaking, there's problems. But if it goes much above 5, then there's different types of problems. So if we fall outside of that range, then we go ahead and raise a failure inside a state, and then we can react to it in some other stateful way. For instance, with a monitoring state, you might kick off a PagerDuty module that sends an alert to somebody. Or you might kick off a call to, you could kick off a call to http.query. But generally what I would expect people to use this for, and my expectations I'm sure are going to change in the future, probably even just in the near future, is you give it a URL, you may give it some post data, you give it whatever, and you give it either match text or status or both. And if it fails one or both of those things, then it raises a failure. And then you move on and handle those the way you normally handle it in states. Have any of you guys worked with on-fail inside states before? There's some really powerful things we could do with on-fail that we can bring into this, right? Say that again? Fire off AWS Autoscaling using the Boto modules, right? Or fire off using this, I guess. I would probably point to the Boto modules, though. But yeah, there's a number of different ways. Yes? Any text. It just downloads it as straight HTML, so if it finds a tag that matches it, then it's going to match inside the tag too. The query state is not really designed to look at the JSON or try to auto-decode that or anything. It's just designed to download and look at those two things. You can do one or you can do both. Let's take a look real quick before we jump into SaltAPI at the monitoring stuff, or the library itself. And you guys see that okay? Yeah, that's what I thought. Actually, let's do this. Is that better? No? That's worse? What's that? Yeah. You know, when you talk enough, you see enough projectors and you see enough problems. How's that? Okay. I don't have the same range on this screen as on my notebook. Let's see if we can adjust that real quick. Okay. So this is the library for SaltHTTP, salt.utils.http. It's got a few things built in that those of you that have spent time in Salt are probably going to be used to. You see a bunch of sick stuff that's showing up. Come on. Okay. You see our SSL stuff in there. First, we check to see if Python itself has the SSL libraries correct, because if it does, we'd rather just use Pythons. If it doesn't, then we check to see if the user has backports installed. And by the way, if you're using requests already depends on the backports anyway, so that's going to be there. And if you're using Salt 2014.7, which hard deps on requests anyway, then again, that's going to be there. And if all else fails, then it's going to try and just import the Salt version. We put it inside salt.ext. So we go down and we have a massive set of things we can pass through. It defaults to a get method. Parameters, these are generally our get parameters. It's weird talking about get when you work in Git a lot, right? GIT versus GET. Data, this is just whatever post data you're looking to send in whatever format is expected by the server. It doesn't try to auto-format that stuff. It's going to assume that you have it auto-formatted already. And this is just passed through as a variable. If you don't have that, you can pass through the location of a file. And as soon as you specify a data file, and again with headers, as soon as you specify that underscore file, it's going to pick that up, shove it through the renderer. Have any of you guys used render pipes at all? I saw, raise your hand, render pipes? Not a whole lot. Render pipes is this powerful concept in Salt where you can render it in one engine, and then render it in another engine, and then render it in another engine, and so on. And the default operation is to render it first in Jinja, and then render it in YAML. So the default operation for render pipes in Salt is that mode. So you can use that to send it through a number of engines as necessary. Using a name password, we're used to that. Decode, if we do another iteration of this, I'm probably not going to call it decode, but this is whether or not to take something and translate it from JSON or XML. By default, it used to be true. This was when we were expecting entirely people to use this just for JSON and XML. And just before 2015.2 came out, I switched it over to false because I wanted to be able to use it more reasonably from other areas as well. These next couple after decode type, by the way, decode type is auto, JSON, or XML. And this is where it tries to figure it out if decode is such true. Status, headers, and text are kind of weird ones. This is whether or not the return dict from this library is going to return to you an item called status, an item called headers, or an item called text. And by default, it returns none of those things. It's trying to be as lightweight as possible. So if you need those things, make sure you pass it through. Cookies, these are, I don't remember what the cookies one does. I might have to go down and look in a moment. This may be the session cookies. The cookie jar, I specify a jar file a little bit further up. We just use a cookies.txt. There's our session jar file, cookies.session.p, because we do things in message pack here. You can change the user agent. The default one is probably fine. Okay. The cookie format, I defaulted LWP, not because I'm an old Perl guy, but because LWP is easy to debug. That's about it. And the Mozilla one, does Firefox even use the old Mozilla format anymore? I don't know that it does. I remember hearing at some point that it doesn't. So LWP is that. Whether or not we're going to persist the session, you see the session cookie jar. It just keeps going, doesn't it? If you don't use render pipes, so with render pipes, you would actually put at the top of the file hashbang pi, for instance, to use the Python renderer. If you're not doing that and you haven't specified a renderer in Salt, you can specify here which renderer you're going to use, both for the data file and for the header, and for, template dict is so you can pass through variables to be used inside your rendering. So things outside of the normal Salt dict. Test mode is kind of an interesting one. With test mode, and this is different from the state test mode means that I'm going to go through and I'm going to build everything that I would normally build, but I'm not going to submit it to the URL that I normally submit it to. I submit it to the test URL. And that way I can reliably look at my tests and make sure they're going through against a server that's not going to cause problems. When I'm ready to go, I just turn off test mode and keep going. Node, whether or not this call is being made from a master or being made from a minion. Port, standard stuff. Ops. This is done from inside salt.utils.http. SaltUtils doesn't have access to all the Salt built-ins normally. Things that we're used to getting inside execution modules and runner modules. It doesn't have access to those normally, and so you need to pass them through. This means you can also use this library from somewhere outside of Salt, and if you happen to be requiring ops somewhere along your tool chain, you can make them up and pass them through as well. Request lib is set to none. It actually defaults to false, but set that to true, and it'll use request instead of HTTP. We're almost done here. Text out and headers out. I don't recall. It's embarrassing. And decode out, stream and handle. There's some interesting cases in which when you're making a web call, you don't necessarily want it to return the data to you all nice and prettified. You just want it to return to you a file handle. And so those essentially do the same thing. They're both there to make it more comfortable to people that are also already used to using the libraries. Okay. Oh, and the agent is the other user agent. You guys saw me define it up top. And then ** quargs is if you have options inside requests or urllib2 that you want to pass them through inside the quargs as well. Okay? Is this a pretty intense function already? And most of this stuff inside here is just, there we go. Master minion node type is which which place to get default ops from if you haven't passed through ops and if it doesn't have them available. Okay. So questions about the library, the Salt HTTP, SaltUtils.http library. Does it seem like something you might make use of? Did I hear a laugh? You think you might use it? Yeah. In a moment, we'll talk about it. I don't know if I have a walkthrough set up, but keep that in mind and remind me towards the end, okay? What time are we out, Katari? No, what time do we get out, though? 11:30? Okay, I'll try and hurry and get to you, okay? And I'll tell you one of the use cases that I've been dying to put together, but when you're getting ready for SaltConf, there's just no time for anything else, any of the fun stuff. But I'll talk to you about a concept that I have. And I haven't asked Tom, but I'm kind of suspecting that this might have influenced the naming of one of his recent additions to Salt. So SaltAPI, like I said, it provides a REST interface to the Salt master. Normally, back in the old days when Salt first came out, people would log into master, they would run Salt, the Salt master as root, they'd log into the root account, they'd do stuff. It didn't take very long before people tried to sudo stuff, and because that's how we've learned to do things since Ubuntu came out. And I expect there's probably some breakage from that, and that got fixed. And then people started running the masters as Salt. All these different methods of dealing with Salt, with people dealing with Salt on the master, this just gives us a REST interface so we can deal with this somewhere else. It uses the external auth libraries, like I said, to provide authentication to this. You do need to have a user inside whichever library you happen to be using. If you're using straight LDAP, which is for some reason not the big use case, then it just needs to be an LDAP. If you're using PAM, then they need to actually have a physical user in the system, even if it's just getting it from LDAP. Now, personally, from a security point of view, I would rather do it from LDAP. Yes? This one, I think, was just working in Cherry Pie. I think it was Halite that did Cherry Pie or the other two. They escaped me. And I know there's been a lot of work with Tornado lately. And I have not been privy to any of that. I've seen messages go through that I ignore because I have other stuff. But by default, it's going to be using Cherry Pie. Don't use HTTPS. I'm sorry, don't use HTTP. Use HTTPS, please. I say that because I always use HTTP because I'm not doing a lot of production work. And debug mode provided, just meaning it dumps out a whole bunch of crap to you from the command line. Okay. Configuring external auth. This is inside the master config, inside etc salt master, master.d. Set up, first of all, PAM or LDAP. Give it the user that you're going to be using. And you're going to need to have runner and wheel. Okay? Those are it's not groups, I don't remember what we call it, but you're going to need to have runner and wheel set up. And the other thing, that star or that dot star, is a regular expression that means all the other parts that you're going to give people access to. This is the thing that you can actually configure here and say, I only want people to have access to run high states, or I only want them to have access to the HTTP module. Or I'm really dumb, so I'm only going to give them access to command and think that that's going to be secure, right? It's like giving people sudo access to Vim and nothing else. Doesn't work. Okay. Also, since we're dealing with Cherry Pie, you're going to need to set up a REST Cherry Pie stanza. Give it a port. Give it a host. Give it some certs. Don't use self-signed ones. You guys know this drill, right? Authentication. Now, there's a couple different ways to use SaltAPI. The main way, this is the way that it was started with, and up until very, very recently, the only way to do it was first off, you make a call using curl or using whatever method. You make a call to log in and generate a token. You receive that token, and then use that token to make subsequent requests. And that's a pretty standard way of dealing with APIs, right? That is not the only way to do it. Oh, and there's sending a command using the token that you've now received. That's not the only way to do it. Webhooks were very recently added. In fact, they were added probably about 2 weeks before I needed them for the customer that I was using the HTTP stuff for. So the idea behind a webhook is we don't have enough time to make multiple calls to properly authenticate us against a system. We have one shot. We make one call, and it has to do all the things that we need it to do. Now, SaltAPI has the support for webhooks now, which means we don't have necessarily a token-based login because we don't have time for that. When a webhook is called, so when you normally call SaltAPI, it just calls out and performs whatever action you're calling over SaltAPI. When you call a webhook, it's going to fire an event over the event bus. And it's going to be sent to the event reactor, and the event reactor can pick that up and do stuff. Okay? That information that comes in, it's entirely up to you to authenticate, to make sure it's valid, make sure that it came from the right source, make sure that, and if we're just doing this entirely inside our infrastructure, this is easy stuff. We make up some passphrases and we send those along the wire, and we're good. When we're dealing with other places, it's not so easy. Let me see if I can find. I had this open on my other computer yesterday, and it doesn't like me. So we've got a blog post up here on the PagerDuty one. It's awesome because it was the first hit yesterday. And that's not it. There we go. And that wasn't even the one I wanted. Have any of you guys ever looked at the Autoscale reactor here? There's some scary stuff. I know a couple of you guys in the back have. I talked to you guys about it extensively. The idea behind this guy is that, sorry guys. Can you see it okay? The idea behind this guy was that when we spin up a machine with EC2 using the Autoscaler, we don't necessarily have a way to move that into the Salt master. And the problem with the Autoscaler is that a machine may exist for only an hour. It might exist for 5 days, it might exist for an hour, but during that time we want it to be salted. And it's not like you're going to have some guy watching for autoscaling events and hurry and log in and salt them or use whatever method they want to use to do that. We want them to be done automatically. And when they get autoscaled back down again, then we want to be able to remove the keys so we don't have junked up keys laying around. So that's kind of the idea behind this. You see that it's, first off, this is a reactor that's built in Python. One of the nice things about the renderers. We see that first off, we get a request we get that webhook from Amazon. We want to make sure that the certificate that it's telling us to use to verify that they're good actually comes from Amazon. That's our first line of defense. If it doesn't, we throw it away. In fact, we send off an email that says, sorry, this came from the wrong URL. If it's the right URL, then it goes and downloads the certificate. It does the checking of the certificates and everything. This is what I mean by actually going and doing your own validation. The webhook itself isn't going to do it for you. Okay? And this guy down at the bottom, when we're done, we do a runner cloud.create. It basically calls off Salt Cloud and says, I already have a machine, so skip that part. Just pick up from there, wait for the machine to come up, get it salted, and so on. Okay? Questions about webhooks so far? Okay. I've got to kind of soldier through here. I've got like 4 minutes and a lot of slides. So tags that come in through SaltAPI, they're going to start with salt/netapi/ whatever the URL is that you've configured. In my case, I've configured webhooks to come in with /hook. A URL looks like /hook/myreactor is going to be salt.netapi hook myreactor. And if you guys look through the docs for the EC2 Autoscaler reactor, you'll see some examples of that. Inside the master config, we set up a reactor dictionary. We tell it which tag to look for. We don't need to wildcard this or anything. It's going to come in specifically on that. Point it over to the SLS file it's going to use to pick that up. And in the SLS file, I'm skipping all of the authentication stuff. We're just going to assume that this is good and happy and say, OK, do a command.run, and in this case, just touch a file. It says we're finished. It's basic stuff. OK. Oh, well, we've got a slide here about the enterprise GUI. Is Matt in here? So somebody added the slide on me, and I found it this morning. And I wish I could speak to it. In the back, somebody was asking a question. I said to hang on to it. What was your question again? Right. I don't have a demo set up for that. What I would do is I would probably skip the tokenized part and move directly to webhooks and establish some sort of passphrase that you can use to make sure that it's a valid call. Maybe do some URL checking or something. There was another thing that I wanted to bring up. I said I'd mention this. The idea I'm calling Beacons of Gondor. You guys have seen those movies, read those books? You know what the Beacons of Gondor are? What's that? So we're talking Lord of the Rings. Gondor is one of the nations. Rohan is another one of the nations. Gondor is in trouble, and so they light a beacon. And then the next people down the line, they see that, and they light their beacons. And I think it's 9 beacons down the line. It gets to Rohan, and Rohan says, Rohan will answer. And they come off and help them out in battle. If you look at the http.query stuff, and you look at SaltAPI, you have this ability now, not only just inside your own internal, one single Salt cluster. I'm going to call them a Salt army. I'm just going to take that liberty and say that now Salt armies have this ability to, once they've established that secret phrase or whatever, they have this ability using HTTP to call out to SaltAPI somewhere else and make a request. And then that guy could process it and call out to another guy and make a request. And he could process it and call it and keep on moving down the line. So now we have this awesome power of being able to have multiple disparate infrastructures be able to communicate with each other and orchestrate even outside the realm of our own data center or even our own collection of data centers. Does that make sense? That's some pretty powerful stuff to think about. And this is where I think that the Salt utils HTTP stuff is going to be really, really powerful. Okay, I think I'm out of time. So thank you guys.